Welcome to CSES group, guys. This is the second part of your 2018 control system electrical engineering optional paper. Question number 7a of 2018 was for the open loop transfer function GSHS is equals to 1 upon S plus P1 into S plus P2. Sketch in Equus plot and comment on the stability. So we are given with one open loop transfer function. A generalized function is given to us, and the poles are mentioned as they are greater than 0. Okay. Now we need to find out its Nyquist plot. For that, we need to first find out the magnitude and then we need to find out the angle. Okay, so magnitude of any given system or open loop transfer function can be identified by making it sinusoidal form, that is S has to be replaced by j omega. Okay, so this GSHS I am replacing by j omega and h j omega. That means what you have to substitute S by j omega. That's it. Then you need to take the modulus of this complete function. So how to take modulus of such kind of function? So a plus jb is given to you, then mod is under root a square plus b square. Okay, so that's what I am doing here. It's very simple. Magnitude for any complex number you can find out by using this method, and that's what is given here. Omega square plus p1 square, omega square plus p2 square, and everything under root. Okay, and angle is given by tan inverse of b by a. If a plus jb form is given, then angle is given by tan inverse of b by a, and that's what we are doing here. The imaginary part divided by the real part. So imaginary part is omega, real is p1. Similarly, minus of tan inverse omega by p2. Please remember, guys, when you are having denominator function, then you need to start with a negative sign. If you are having numerator polynomial, then for angle we need to start with the positive sign. Hence I am writing negative for both the angles. Now this is written as tan inverse of a minus tan inverse of b, both with negative sign. Negative you can take common, so tan inverse a plus tan inverse b can be easily solved in this way. Okay, now for plotting the Nyquist curve or polar plot, you must have at least three values of frequency and their corresponding magnitude and the phase. So three values of frequency means what? Omega is equals to 0, is equals to infinity, and you can consider any value. I'm considering 1 here. For omega is equals to 0, you can easily verify from this equation that if you substitute omega 0, this will turn to p1 square. If you substitute omega 0 here again, then p2 turns, this will turn to p2 square. That means p1 and p2 multiplication, and that too under a denominator, because that over root will be cancelled out by this square terms. Okay, so you will find magnitude is 1 upon p1 p2, and the phase angle will become 0. Why this is 0? Look at this tan inverse formula. If you substitute omega is equals to 0, everything will turn to 0. So phase is 0 there. When you substitute omega is equals to infinity, again this equation, the denominator will turn to infinity and the magnitude will turn to 0, and the phase angle will become minus 180. So these 2 points you have. That means for frequency value 0, the magnitude is there but phase is not there. For omega is equals to infinity, the magnitude is 0 and the phase is minus 180. For any point, let us say omega is equals to 1, you can do this calculation, substitute omega value and find out the corresponding points for magnitude and the frequency. Now look at this, guys. This omega for 0 plus will go in this way, okay, in this direction towards the omega is equals to infinity. Okay, so polar plot or the Nyquist plot is always symmetric with respect to the horizontal axis. Hence you will get the upper curve also in this way, and you can easily find that there is no pole in the right hand side of the S plane in open loop transfer function. Hence there is no encirclement of this minus 1. The complete encirclement is with respect to the origin, or we can rather say that minus 1 plus j0 will not be having any encirclement with this open loop transfer function, and all the poles are lying in the left hand side of S plane. That means the system is stable, no encirclement, all poles lie in the right hand side of left hand side of the S plane, sorry. Hence the system is stable. Now I have considered some value of p1 p2. I have considered p1 is 2 and P2 is 3, and I have plotted the Nyquist curve for the same, okay, using Matlab, and you will find a similar sort of Nyquist curve you are getting, and there is no encirclement of -1 because all the values are lies in the left hand side of the S plane. Okay, so what will happen? This is -1, -2, and -3 basically. So this is what the Nyquist curve. -1 is lying here. Please look at this, the range of the axis, horizontal axis. This is your -1, and the Nyquist curve is getting back to the origin in this form. Okay, so it is starting with this. This is your origin line. So this is your origin. You can easily do that calculation. Okay, this point is, yeah, this point is the origin. Look at here, this goes with this 0, and there is no encirclement with the -1, and it starts with uh, a magnitude for some value of omega, or omega is equals to 0 in that way, and it is encircling in this way, and it is going back to that value. So omega is equals to 0 plus, it is here, omega is 0 minus, it is here. Okay, and omega infinite plus is here, and omega infinity minus is here. So this is what the curve we got in our normal method also, and that can be verified using the Matlab also. Okay, so system is stable. Let's go to the next question. Next question is 5e. For the characteristic equation given by this, by Routh-Hurwitz, determine the stability. So stability means the question is asking how many roots are lying in the right hand side of the S plane. Okay, so RHS of S plane. So this can be easily identified using the this can be easily identified using the Routh-Hurwitz tabular form, which shows that if there is a sign change, that the number of sign change is equals to the number of roots lying in the right hand side of the S plane. So I'm writing the coefficients of S4, S2 and S0 in the first row, that is 1, 10 and 100. Then coefficient of S3, S1 in the second row, that is 3 and 20. Then cross multiplication in this way, 3 into 10 minus 20 into 1, that is 10 divided by 3. Okay, so 10 by 3 is 3.33, I am writing here. Then 3 into 100, then 0 into 1 divided by 3. Okay, so 300 divided by 3, that is 100 again. And again do the cross multiplication. So cross multiplication of 3.33 with 20 and 100 with 3 divided by 3.33. Okay, so if you do this calculation, you will find that this comes as to be minus 70. This will become 0, and again the cross multiplication, minus 70 into 100, that is minus 7000 divided by 3.33 into, sorry, minus 70 into 100 minus 0 into this value, that is 0 divided by 70 again, so this comes out to be 100. Now you can easily verify that there is a sign change when you are transiting from 3.33 to 70, and there is a sign change from minus 70 to 100. Okay, so there are basically two sign change. One is here, plus to minus, and then again the other one is minus to plus, that is here. This shows that the given question or the given system is having two sign change, hence two roots are lying in the right hand side of the S plane. And we have used Matlab to calculate the actual roots of the given question or the given polynomial. So this comes out to be 1.015 plus minus j 2.75. Obviously this is in the real part is lying in the right hand side, and that's what your answer. Okay, so two roots are lying in the right hand side, whereas the other two roots are lying in the left hand side of the S plane. Next question of 2018 is question number 8b. Consider the block diagram given as here. Write the differential equation relating to theta to E, and hence the state model for the system, choosing theta t and theta dot t as the variables. So you're having the transfer function here. Let us write the transfer function output by input. So theta s divided by es is equals to k upon s square t plus s. So this is what I am writing, and then do the cross multiplication. So denominator of right side will go to the numerator of left side, and the numerator of left side will go to the denominator of the other side, right? So in that you will find this equation, and then you have to take the inverse Laplace of the above equation. You will find this theta s will turn to theta t, s square will go to d2 theta t divided by dt2, and t will become as it is. Again, when you are having s, that means it is the first differentiation, and theta s is the factor, so that will change to theta t. Es will change to et, and k is constant, hence it will move as it is. Okay, so you can easily write the differential equation in this form also, that second order differential is of theta t is equals to k by t into ct minus 1 upon t d by dt of theta t. Okay, so this is what you got. Then the state space representation of the above model is drawn here. So please remember, the generalized method is the number of integrator and number of summer is equals to the order of differential. So order of differential is 2, but I am using only one summer because you don't have any term, the third term here, that is without differentiation. Okay, so that is not there, hence you don't have any summer for that. So I'm writing one integral here, the other integral there, and at this point I am considering as d2 theta divided by dt2, which I'm writing as x2 dot. Then integration of this will go to the first order differential of theta t, that is d by dt of theta is equals to x2, which is equals to x1 dot. Now integration of this again will turn to theta t. Okay, and from this point I am taking one input, providing it to 1 upon t with a negative sign, and providing to the summer here. Now if you see this point, this d2 theta upon dt2 is equals to kt by c, so kt by et, this is e, this kt multiplied with et minus 1 upon t into d by dt of theta t. Okay, so d by dt of theta t is here, which is going to 1 upon t with negative sign and going to this summer. Hence the first equation is done. Now let us define the state variable as per the question. So I am writing x1 is theta t, x2 is theta dot t, that is d by dt of theta, and x2 dot is second order differential of theta t. Now using the diagram we can easily write that x1 dot is x2. Where is x1 dot? Let me remove the annotations. So x1 dot is here, x1 dot is equals to x2. Okay, so that's the first equation. Then x2 dot is here, so x2 dot is equal to minus 1 upon t into x2. Why x2? Look at here, this is your x2 point, which is getting into this block, that is minus 1 upon t, and then going to this summer. Hence this term is coming, and then k by t of et. So this et is here multiplying with k by t and going to the summer. Okay, so in this way you can write the x2 dot equation. From here you can just write the state space analysis matrix diagram or matrix equation. So x1 dot and x2 dot will come in the left side of the matrix, and the coefficient matrix will be written as 0 1 because you don't have any coefficient for x1, hence 0. X2 have coefficient 1, that's why I am writing 1 here. You don't have any coefficient for x1 in the second equation, hence 0 again. For x2 the coefficient is minus 1 upon t, look at here in this equation, that is why you are getting this. Then you don't have any et term in the x1 dot equation, hence 0 is coming there, and then you have k by t coefficient for the et in the second equation, hence that is writing or written here. Okay, so this is what the state space representation, this block diagram and this matrix give the state space representation of the given system. And also don't forget to write that x1 is equals to theta t and x2 is equals to theta dot of t, which is equals to d by dt of theta. Okay guys, this is what is mentioned in the question. Okay, so that's very important to note it, that now we are able to form the state space analysis or state space representation of the given system. Okay, let's go to the next part of this question. 8b second is sketch the Bode plot of a lead compensator. Okay, so lead compensator, basically high pass filter works as a phase lead compensator. So I'm writing one phase lead compensator here. So this is what the transfer function of the phase lead compensator, where the alpha value is less than 1, and which is given by R2 divided by R1 plus R2, and the this t is given by R1c. Okay, so this can be easily solved by considering a loop here and a loop there. Okay, so you just find out E0 by E1 and you will end up with this. So before that I have converted into Laplace equation, and then I have utilized that method to write the transfer function of the given system. Now for sinusoidal response, because we are looking for the Bode curve, then obviously sinusoidal response we need to see. So S has to be replaced by j omega, and you will end up with this equation. Okay, now the Bode curve of the given uh, function looks like this. How we are getting? We have to substitute the value of omega there, and we need to find out the magnitude and the phase. So phase angle is given by tan inverse of real by imaginary, sorry, imaginary by real. So omega t upon 1 minus omega alpha t by 1. Okay, so your phase angle is given by tan inverse of omega t minus tan inverse of omega alpha t. So with this you can easily identify what is the value of phase. Okay, so you need to substitute some value of frequency between between 1 upon t to 1 upon alpha t, and you can easily find out the phase and the magnitude of the given question. So what I did, I have considered some value of alpha, that is 0.093, which is here, and the omega m value is 16.5 radian per second. So substituting so in this transfer function, you will get the corresponding transfer function as this, and I have used the Matlab to plot the Bode curve of this transfer function. So you can easily verify that this is also a high pass filter. Okay, so low frequency values are suppressed here. This is magnitude 0, and the high frequency values are passed because the cutoff frequency somewhere lies somewhere here. Okay, so for high frequencies you are having a gain, and for the low frequency you don't have any gain, you are suppressing everything. Okay, and this is what the phase curve for that's what we have drawn for our generalized function. And you need to check that the frequency for 15.8, you are having magnitude as 10.1 and the corresponding phase as the 56. So this is the maximum phase which we have received from the given question. Thank you guys, that's it for this 2018. Please subscribe the channel, give your comments such that this will give me the motivation and how I can improve the content for you. Thank you. Jai Hind.